All right, so I'm going to go through the midterm review. So question number one says to identify the key features for the graph. First thing we've got is the range. So with the range, we have to remember this is going to be the y's. So we're looking for the y coordinates. And remember, we want to go low to high. So we want to find the lowest point on the graph in terms of the y's. So the lowest point is all the way down here. And that's at -5. We got count 1, 2, 3, 4, 5. So that's at -6. It's an open dot, so we want to make sure that we have a open parentheses. Then to get the other coordinate, we're doing an interval, so the highest point, if we go all the way up, we got our choice between these, but they're the same. They're both at 6, and they're both closed dots. So even if just one of them was a closed dot, we would still get to make the closed bracket. So that's what we got for number one. Number two, we get to do the domain. Domain is going to be the x's, so we're going to look at the x's. So we're looking to see what's on the most left of this graph. So all the way to the left is this dot right here. And if we follow this down, this is at -1 to -3. So it is a closed dot, so we get to put a -3 there. We have to be really careful with the domain since there is an open dot over here. Technically right here at -1, the graph doesn't exist there. So we want to say we're going from -3 to -1 because there's an open dot there. And we're going to have to union that with -1 because then we're going to start up again right here. And as we keep going, we hit another open dot all the way at the end at 6. So -1 to 6, and that's another open dot, so we have to do another open parentheses. So that's our domain. It is pretty tricky, but we have to recognize that there's not actually a point at -1, which is why we have to have these parentheses at -1. We can't include -1 because there's no dot at -1. For part 3, it says positive. So what we want to do is look at the x-axis, which is right here. And anytime we're above this, then we're going to be positive. So that means we're going to start positive here, and we're going to end being positive right here. So this is from -3 to -2. Again, when we talk about positive, we're only talking about the x's. -3 is a solid dot. And when we're talking about positive, it's 0 at -2. So we have to do an open dot here because we're switching from positive to negative. So we can't make it a solid dot because it's 0, and 0 is not positive and it's not negative. Then there's another section. So we're going to do a union because we've got two parts where we're above. So that's going to go from here. We're going to go all the way up and then all the way back down and then end right here. And that's going to go from 1 to 5. Now those are both going to be parentheses again because these are at 0. 0 is not positive. So these are kind of like open dots on this positive spectrum. Then the last part, we have to do the average rate of change. So to do the average rate of change, we have to use the average rate of change formula. This is going to be A and that's going to be B. So the average rate of change formula is f of B minus f of A over B minus A. I'm just going to switch that so it looks a little bit nicer. And we have to remember these are A and B. So this is not an XY coordinate. This is like X1 and X2. These are A and B. So the good thing is that we know A and B already, so we can just plug those in, 0 and -2. And then what we have to do is we have to get the function values there. Remember, f of B and f of A is like the y's. So what we need to do is we need to find -2 as an x, which is right here. And we need to put in its function value. Well, it's right at 0. So we'll put a 0 right there. Then we have to do the same thing for B. What color have I not used yet? I used all of them. We'll grab a new one then. So then for B, this is 0. So I need to find the y value at 0. 1, 2, 3. And that's at 0, -3. So I know I've got -3 for f of B. So when I simplify, -3 minus 0 is -3. 0 minus -2 is like 0 plus 2, so that's 2. And we can leave it like that. We can just leave it as a fraction, and that's good. So it's like a slope. And again, that checks out because if we were to do a slope, if we were to connect those with like a fake line, we'd be going down 1, 2, 3 over 2, down 3 over 2. So that does check out. That makes sense. That's the average rate of change. All right, for 5, what's the equation that for y equals x, absolute value of x minus 1, plus 3 reflected across the y-axis? So the whole point of this one is you have to remember back from the section where we did all of our reflections. If we're reflecting across the y-axis, what we want to do is we want to change all the x's to negative x's. That's going to reflect our function across the y-axis. So y equals negative x minus 1 plus 3. And that negative x minus 1 is in the absolute value bars. And that's it. So we're done. If you want, you can double check it. You can graph them both in your calculator or in Desmos just to double check that it does reflect across the y-axis. So again, real quick, we're going to start. So we'll go right 1, up 1, 2, 3. We've got a slope of 1. So our original function is going to look like that. So the goal is we want the final function to be reflected. That's really thick. Whatever, we'll roll with it. To be looking like this. That's what we want our new function to look like because we want it to reflect across the y-axis. All right. For 6 pages, filling a 4.5 liter bucket at a rate of 0.2 liters per minute. What's the domain of the function that represents the volume of water in the bucket after x minutes if the bucket was initially empty? So if it's initially empty, that means it starts at 0. And we want to fill the entire bucket because we want the domain. So we want to find out what happens when it gets all the way till it's filled. So we want to find out what it's filled at. But it's filled at 4.5 liters. We know that this is at time t equals 0. And so we want to find out what x is going to be because we have to find out how long it takes to fill up the entire bucket. So what we want to do is we want to divide 4.5 divided by 0.2 divided by 0.2 liters per minute. And again, if you want, you can just follow the units on this one. This is like a chemistry stoichiometry question because the liters would cancel out. And then these minutes on the bottom, since it's a double fraction, would come up to the top. So that's how I knew I wanted to divide because that's how the units are going to work out. 4.5 divided by 2 is the same thing as 4.5 times 5. Again, these liters will cancel out. These minutes are going to travel up top. So that's going to be 20, and then 0.5 times 5 is 22.5. So there we go. If you want, you can also do this a lot of different ways. You can write an equation out if you don't want to straight divide. In this case, our equation we would say is y equals 0.2x because we're gaining 0.2 liters every minute. And it's actually going to be plus 0 because we don't start with anything. So the question wants to know what happens when we get to 4.5 liters. So 4.5 equals 0.2x. And again, we can see, to solve this, I just divide by 0.2, which is exactly what we did down here. So there's a lot of different ways that you could do this one. I chose to do it the first way, like a chemistry problem. But if you wanted to set up your linear equation, you could do it that way. All right, for number 7, identify the translations of the parent function f of x equals x squared that give g of x equals x minus 8 quantity squared plus 7. So we want to identify that this negative 8 inside the parentheses is going to be our left and right motion. If we have a minus sign, that means that we're going to the right 8. So if I look at my choices, that's left 8, that's left 8. On the end, this is going to be my up and down motion. We've got a positive 7, so this means we're going to go up 7. So this is the choice that says up 7 and right 8. And again, we did some of these in Unit 1, so this is kind of what we did in Unit 1. If you want, you can also use the formula from Unit 2. Not A equals. Y equals A x minus h squared plus k. And then we can recognize, okay, I can see that h is going to be 8. K is going to be 7. So if I want to get my vertex to be at 8, 7, I'd have to go to the right 8 and then up 7. So I could do it that way too. And again, you can also throw it into Desmos or your graphing calculator. Just start with f of x equals x squared, which has a vertex at 0, 0, and just follow the vertex. So that's another way that you can do that one. For number 8, graph this piecewise defined function. So it's been a while since we did the piecewise functions. But remember, we want to take our endpoint and we want to plug it in for the x value. So we have 1/2 times 4 plus 1. Half of 4 is 2. 2 plus 1 is 3. So I need to put down the point. Oh, we have to do -4. So half of -4 is -2. -2 plus 1 is -1. I think I caught that. All right, so we have -4, -1 as our first point. Now, you might be tempted to go 1, 2, 3, 4, but if I look at my graph, it's going by 2s, because this is -10. So this would be -2, -4, -6, -8. So -4, -1 would actually be right here. We also know it's got to be a closed dot. So I made a closed dot there. And that's because we've got the or equal to sign. So since it's a less than or equal to, it's going to be a closed dot. Next one I got to plug in then is I got to plug 0 in for the x. So we'll do 1/2 times 0 plus 1. Well, that's nice because that's just 1. So I got to plot the point 0, 1. But this time, since there's no little equal sign, we know it's got to be an open dot because it's just a less than sign. So again, I got to be careful for counting 2, 4, 6, 8, 10. I don't want to put it right here, even though that would be 1 if we counted. Based on the scale, I've got to put it halfway in between. So then I'll connect those with a line. It's not the best line, but it's a line. We'll call it a line. For the next one, well, this one's nice because we just have the number there. And we said the number is pretty easy because the number means that we can just say this is going to be 0, 1, which is going to be open. And we'll have 3, 1, which is also going to be open. So there's no math to do on this one. You just have to recognize that if we just have the number, it's just going to be a flat line, in this case from 0 to 3. So I'm going to trace over this one because it is open in the same spot. If it was closed, I'd get to fill that dot in, but it's not, so I don't. 2, 3 would be about there. So again, we'll try and draw a flat line. So we've got our second piece done. For the last piece, we use the final equation. We'll plug 3 in for the x. So it's going to be 3 plus 2 is 5. So we've got 3, 5. Again, that's going to be closed because we have the or equal to sign. So 3, 2, 4, 5. I got to estimate, but it's nice. It's right in the middle. Then I got to plug in the 8. So I get 8 plus 2 is 10. So I have to plot the point 8, 10, which is going to be open because it's just a less than sign. Oop, there we go. 2, 4, 6, 8, 2, 4, 6, 8, 10, and open. And there we go. So we can see sometimes the pieces will actually connect. So that's kind of fun when it does connect. Sometimes they don't. Sometimes there's a jump discontinuity in there, and that's okay too. But that question's done. So we just wanted to graph each of the pieces. All right, for number 9, which of the following sequences are arithmetic? Select all that apply. So we do have to check every single one of them. So what we have to do is we want to add or subtract because we're doing arithmetic. So we only want to check for adding and subtracting. So as long as we're adding or subtracting the same amount every time, it's going to be arithmetic. So for the first one, to go from 1/2 to 1, we have to add a half. Not plus or minus, just plus a half. All right, if I want to go from 1 to 3/2, we're adding a half. If I want to go from 3/2 to 2, I'm also adding a half. Since those are all the same, choice A works out. All right, for choice B, if I want to go from -2 to 6, I need to add 8. If I want to go from 6 to -18, I need to subtract 24. So right away, I can see that those two are different. So I know I can get rid of choice B. I don't want to pick that one. Next choice, choice C. If I check from 48 to 37, I have to go down 11. 38, 37. Yep, okay. 37 to 26, I'm also going down 11. 26 to 15 is also down 11. So that one works out. So that works out every time. And then the last one, choice D. So we've got 1/3 to 1. I have to add 2/3. And then 1 to 3 is going to be +2. Well, those are not the same. So again, I can get rid of D. For D, if I didn't want to work with the fraction, I could see 1 to 3 would be 2, and then 3 to 9 is going to be 6. So you could also see it with the whole numbers if you want. Same deal, if you are more comfortable with the decimals and the fractions, you can turn all the fractions into decimals and then work from there. All right. For number 10, write the first 4 terms of the sequence defined by our nice piecewise function here. So with our recursive sequence, we can see that we're going to start at 7. So this is just telling us that 7 is the first number. So the first number is 7. And then the instructions here say to subtract 4 every time. So we just have to follow their instructions. 7 minus 4 is 3. 3 minus 4 is -1. And then -1 minus 4 is -5. All right, well, I have my first 4 terms, so I'm done. That's it. That's all we got to do. So the big key is just remembering what the structure of that equation is telling us. For 11, in a theater, there's 3 chairs in the first row. Each row has 2 more chairs in the previous row, and there are 12 rows. How many chairs are there in the theater? So this one's really well set up for, oh, you know what's going to come. There it is. That looks like it's going to be the best way to do this one. Because it tells us that we've got 12 rows, and our function's very nice because it tells us that we've got 2 more chairs in the previous row, and we've got 3 chairs in the first row, so 3 plus 2i minus 1. I got to bring up Desmos, but we're just going to throw this into our calculator. This is a really good one for sigma. So let's get that going. We want the sum. Change that to an I just to be consistent. And our function was 3 plus 2i minus 1. And it gives us a nice number, 168 chairs. All right, pretty good. So if we didn't want to use sigma, which I guess you might not want to use sigma, but the intention is to use sigma, and part of the challenge is using some of the faster methods that we had in class, not relying on some of the stuff that we do in Algebra 1 in order to get everything done on time. If you didn't want to use sigma, you'd have to use the other equations that we have. So the other equations that we had were a sub n equals a sub 1 plus n minus 1 times d. So we'd have to fill everything in for this equation. So in this case, a sub n is going to be, we need to get the last number. So we're going to plug in a sub 12 because we're trying to figure out what the 12th row has. A sub 1 is how much is in the first row. So there's 3 chairs in the first row. N minus 1 stays as, well, no, it doesn't stay. We know how many rows we have. We have 12 rows. So we've got 12 minus 1. And then D is how much we go up by every time. We're going up by 2 every time. Or not up. Yeah, we are going up by 2 every time. So this is going to simplify to 3 plus 22. 11 times 2. So a sub 12 is 15. But then we have to use another equation. Then we have to use the s sub n equation. So we're introducing even more equations into the mix. S sub n we said was going to be a1 plus an all divided by 2. We have to multiply that by n also. So this is going to be a1 is 3 because we got 3 in the first row. We've got 25 in the last row. We're going to divide by 2. And we need to multiply by n. In this case, n is 12. So when we do this calculation, this is going to be 3 plus 25 is 28. And I'm going to do 12 divided by 2 first, just because that's going to be a little bit easier. And this is going to be 120 plus 48 is 168. So you can do it either way. But again, the intention is to use the sigma form, not to do all of this calculation. Because again, part of the challenge and part of why it's a time test is that we want to learn how to use all of our symbols efficiently and not have to use some of the longer methods. So there we go. All right, so we're doing number 12. I had to fix my graph on number 12. So it says use a graph to solve negative absolute value of x minus 3, and then plus 5 is less than or equal to 0. Your graph will be scored. So the idea is we want to graph each side of the inequality and then come up with a final answer for where we've got a double shaded region. So we can graph negative absolute value of x minus 3 plus 5, since we can recognize all of the ways that it transforms. So in this case, we've got a minus 3. That means that we're going to go to the right 3 with our vertex. We can see we've got a minus 5. That means we're going to go up 5 for our vertex. So we can put our vertex in. And again, I got to be careful. I'm counting by 2s again here. So 2, 3, 2, 4, 5. So I know the vertex is right here. Normally for these absolute values, remember they're the v-graphs. We see out here that we really have a 1 out here. So we know we're going to have a slope of 1. However, it is negative. So we do get a vertical reflection. So instead of having our v facing upwards, our v is going to face downwards. And we have to be really careful because we want to make sure that we actually graph it accurately. So we have a slope of 1 here. So that means if I'm up here at 5, I've got to go down 5 and then right 5. Here I'm at 3, so 4, 5, 6, 7, 8. Here again, I'm at 3 because that's where I started from my vertex. I had to go right 3. I'm going to go back 5. 1, 2, 3, 4, 5. So when I draw my V, and again, I'm going to draw solid lines because I've got an or equal to sign. When I draw my V, I got to be very careful. I want to do a good job with this. So there we go. And again, I'm going to draw my V. Be nice and careful. Go through that. All right. So in this case, we need this to be less than 0. So if we think about this, we can always pick a test point. I like to pick 0 as a test point. If I were to plug 0 in here, we'd have negative 3 plus 5. And we'd get 0 minus 3. Absolute value of that is 3. Negative 3 plus 5 is 2. So I don't want to include 0, 0. So what I would do is I would need to shade this whole section. Shading that section, that section, that section, this section, this section. So that's all shaded. We're going to shade above this curve. All right, so the other graph, the other part of the inequality we've got is we've got the 0 over here. So again, 0, that's an easy one to do. That's just right here. I can't pick 0, 0 as a test point, but since I know I need y to be less than or equal to 0, since the y is on the left side, I can just say, all right, well, I need to go below this graph. I need to go below 0. I can also just pick another test point if I want, like negative 10. I know negative 10 is less than or equal to 0. So I have to shade this whole section underneath. So anything that's underneath 0 also needs to be shaded. So my goal is to look for the double shaded sections, which we can see is going to be like this section and this section. And again, if you're not going to graph it at first by hand, if you want to graph it at first on your calculator, you can. Just remember your answer is going to look something like this. So if you have an answer that just looks like lines or looks like a rectangle or something, you did not graph it correctly. So then we'll grab our answer. So our answer is going to be, we're going to start out from negative infinity, because this blue section is just going to keep going forever to negative infinity. And then we're going to go all the way and stop here. And again, we got to be careful. That's not 1 because we're counting by 2. So it's going to go from negative infinity to negative 2. And then because there's a second section, we get to do another union. And we're going to start here. So that's going to be 2, 4, 6, 8. And that's going to go all the way out to regular infinity. So you can see these are going to keep going out forever and ever. Oops, these are actually going to be solid dots because we do have solid lines. So solid lines means instead of parentheses here, we do get to use the closed brackets. Remember, infinity and negative infinity are always going to get open parentheses because that's not actually a number you can reach. So that's the answer. This is the answer for number 12. So again, a couple parts. The graph itself needs to be correct to be scored, and then also you need to have the correct answer over here. All right, for 13, solve the system of equations. Again, a couple ways to do this one. This one's a little bit strange. So we do have the two y's that are equal to each other. So if we wanted to, we could set these two equal to each other. 2x squared plus 1 equals negative x plus 2. Since we have an x squared, though, we would have to move everything to one side. So we'll have to plus x and minus 2 on both sides of this equation to get 2x squared plus x minus 1 equals 0. Now, at this point, this is somewhere where we might have to say, like, well, hold on. This doesn't seem like this is going to be the most effective way to solve this one. Since we do have the square, that means we're going to have to do like a quadratic. We have to either factor it, use the quadratic formula or something. So I'm actually thinking at this point, well, it might have been faster just to graph it, to solve this one graphically. So I'm going to throw this into Desmos. We're going to see if it's easier to solve graphically. So we've got y equals 2x plus 1, 2x squared plus 1. And then for the other function, I kind of forgot what it was, y equals negative x plus 2. And yeah, I think this is going to be a little bit easier just to solve and just grab these 2 points, because those are going to be the answers, because where they intersect is where our solution is. So let me grab my screen capture here. We'll go ahead and we'll steal our graph. And again, based on my choices, I'm thinking that the graph is going to be the faster choice. I think the graph is going to be the better way to do this one, even though you can do it by hand. I think I'm going to just take these as my 2 answers and call it a day. Negative 1 comma 3 and 0.5 comma 1.5. Since there's both the x's and the y's in the question, we need to have both the x's and the y's as our final answer. If this squared wasn't here, I would say probably by hand would be a little bit faster. But since the squared is here, I do think that the graph is going to be a little bit faster here. And again, if we were to solve this in any sort of method, whether it be the quadratic formula, factoring, completing the square, we'd get negative 1 and 0.5, but then we'd still have to plug negative 1 into this equation to find out the y value, then 0.5 in here to find out the y value. I think the graph is just going to be a little bit better on this question. For 14, write a matrix that represents the system of equations. So this is just about remembering that we want to take all of our coefficients. So 2, 3, negative 8, negative 4, negative 5, 1, and we're done. That's it. So we just have to write the matrix. We have written the matrix. On to the next one. For 15, write the reduced row echelon form for the matrix. So again, in this case, we probably want to use our matrix calculator, or we want to use the matrix features in the TI calculator. So remember, for that, you want to hit the second and then the math button that brings up the matrix menu. You have to go over to the edit menu, and that will let you type in this matrix. So again, how to get there on the TI, let me just write those all out. You'll hit second, and then the math button to get to the matrix. Then you're going to have to hit over twice. And this gets you to the edit screen. You're probably going to pick number 1 for matrix A, because we really only need one matrix to do. And now you can type in the matrix. I actually need to grab the matrix. I didn't bring up the matrix calculator. Oops. There we go. All right. So new matrix A, we can see that we need this to be a 3 by 4. And now I have to type in all the numbers. 25, 9, 4. Those seem fun. Those seem like those are all perfect squares. 5 squared, 3 squared, 4 squared. -5, -3, 2. 5, -3, 2. Well, wait, 2 squared is 4, -3 squared is 9, -5 squared is 25. That seems interesting. 1, 1, 1. Well, that's each of those numbers to the 0th power, to the first power, to the second power. These seem like they're suspiciously chosen. -10, 2, and to -3. -10, whoops, I got to the wrong place. 2 and -3. All right, so then down here, I hit the enter button, so you can hit the enter button to get down here. We want to do the RREF, and we're going to pick matrix A, and then we got our answer. -1, -2, and then 5. -1, -2, and then 5. Double check. -1, -2, 5. All right, sounds good. Nice thing is, again, with the 3x3 matrix, we always want to have this diagonal matrix with the 1s and the 0s. So that part's pretty quick because that's going to be the same for every single one of these matrices. It would be a 3x3 augmented with the solutions over here. To get to the REF, remember that's going to, after you type everything in, you can hit second and then math again. And then you can find the RREF feature. After you press that one, after you get that one in, then you have to go back to second. Oops, I forgot. We have to go over to get to the REF button. Oops, let me hit a little over first. Then you can do RREF. All right, then you'll hit second, and then math again to bring up the matrix menu again. We'll press 1 again to type in to get matrix A to go in, and then you can press enter and it'll give you the results. So that's how you'd want to do it in the TI calculator. Or, I mean, we saw how to do it by hand in class. You could always do it by hand. For number 16, what's the equation in vertex form of a parabola of a vertex 3, -3 that passes through 2, 9? So now we can kind of see we've shifted from stuff that was on the first test. So there were 15 questions that were kind of just like the first test. Now we're doing things that were like on the second test. So that's nice that this is kind of in order. So we've got our parabola with a vertex that passes through a point. That tells me that we probably want to use vertex form. Y equals A, x minus h squared plus k. All right, well, we know that this is going to be h and k. So we're going to plug those in. Y equals A, x minus 3 squared plus -3. You could just put -3 if you want. These two over here are going to be x and y. So 9 equals A, 2 minus 3 squared, and now I'm going to switch that to -3. And now we simplify. The goal is to figure out what A is. We need to figure out A, so we'll add 3 to both sides. So it's going to give us 12. 2 minus 3 is -1 squared. -1 squared is 1, so we divide both sides by 1. 12 equals A. All right. Final answer then, we go back to this blue equation. We say y equals 12, x minus 3 squared. And again, I'm going to switch that plus -3 to -3. And there we go. If you want to double check, again, you can double check it in your graphing calculator or in Desmos. Plug that equation in. Make sure you pass through both 3, -3 as the vertex and 2, 9. On TI, it's pretty nice. You can just hit the trace, type in 2, and it should show up at the bottom of your screen 2, 9. Same deal then, you hit 3, press enter, it should show up as 3, -3. So you can double check that really quick on the TI. For number 17, g is a transformation of f of x is x squared. G is a translation right 4 and up 2. Write the equation for g in the form y equals ax squared plus bx plus c. We're doing this one kind of the same way. So y equals a, x minus h squared plus k. In this case, they didn't tell us the vertex. They just wanted to know what the h and the k values were. So here, since we went right 4, we know that our parentheses should be x minus 4. Since we're going up 2, we know that we need plus 2 at the end, so k is going to be 2. We're given no vertical stretches or no vertical reflections, so a is just going to be 1. So I don't really need to write down a, because a is just going to be 1. I'm going to write that over here, but not over here. So this is not in standard form, because here we have our standard form. So we have to multiply this out. So now we get to multiply it out. Again, if we want, since we've learned the trick, we can actually just use this nice, essentially it's the square of a sum. But if you wanted to go out and practice it like we did in Unit 2, we switch those to both x minus 4s, and we do a bunch of distributing. So, x times x minus 4, minus 4 times x minus 4, and we set the plus 2 on the end. And then we go ahead and distribute again. X squared minus 4x minus 4x plus 16 plus 2. And so you can see, yeah, this was unsurprisingly, yeah, x squared minus 8x plus 16. But when we combine like terms, we'll combine those two to be negative 8x. And so the one reason why you might want to do the distributing instead of just following the tricks from this most recent unit is it does help us to remind us that we do need to add those two at the end. We do need to combine those two like terms. If you use the trick, you might accidentally lose the 2. Just kind of keep that in mind if you choose to use the trick, that 2 does exist. All right, and so that's it. So now we're in standard form, and we're done. Again, if you want, you can double check. You can throw that into a graphing calculator as a TI. Up to you. For 18, path of the projectile from a 32-foot tall platform is modeled by the equation y equals negative 16x squared plus 64x plus 32. Part A says graph the equation. So to graph the equation, I want to find out what the vertex is. So we're going to use our vertex equation, negative b over 2a, to get the x-coordinate of the vertex. So b is 64 in this case. So I'll underline that in black. And then a is going to be negative 16. So we get negative 64 over negative 32, which is 2. So I know that somewhere at x equals 2 is the vertex. So I got the x-coordinate. To get the y-coordinate, what I need to do is I need to plug 2 into the equation. So y equals negative 16 times 2 squared plus 64 times 2 plus 32. So this is going to be 4. 4 times negative 16 is 64. 64 times 2, I'm going to write as 64 plus 64, only because I know these 64s are going to then cancel out, which is going to mean I've got 96. So I want this at 96. So 80, 90, 96. So about there is going to be my vertex. It's going to be at the point 2 comma 96. All right. Well, I need 3 points in order to graph a parabola. So I'm going to grab my other points. But they tell me that I've got a 32-foot platform. And so we can see that the y-intercept is 32. So 20, 32. So that's pretty nice. So we can tell from that we need the point 0, 32. And then we have to use the idea that the parabola is symmetric. So if I'm 2 to the left of the vertex at 32, I need to be 2 to the right of the vertex at 32 also. So I'm going to come over here to 432 and plot that point as well. Make a nice parabola. And I'm going to assume that we stop when we hit the ground. So I'm going to pretend that my projectile just digs into the ground at that point. Just kind of stops. So I've got my graph. My graph is good. If you choose to do this in your graphing calculator or on Desmos, again, I'm looking for these points. If those points are in the wrong spots, you're not going to get full credit for the question. You need to make an accurate graph. I know on the tests, a lot of people tried to do it and they just decided they wanted to put their y-intercept like down at 0. That was wrong. Some people wanted to put their vertex like down here. That was wrong. Some people wanted to have this intersection be like down here at 3. That was wrong. So just make sure that you get your points in the right spots. For part B, we've actually answered already. The maximum height we can see is the top of the path. It's going to be at 96 feet. We already got that. So that's our answer for part B. So, and that's the end of number 18. All right. Next one, 19, use quadratic regression to find the equation of a quadratic that fits the given points. This is a straight calculator question, so you just have to use the calculator for it. If you're doing it in the TI, we'll run through those instructions first. This is where we have to hit the stat button. And we'll press enter to type in our data. After that data is in, we'll hit the stat. We'll press over. Since we want the quadratic, we're going to pick number 5 for the quadratic regression. And then we're just going to press enter 3 times. Enter, enter. Well, actually, no, I was saying the other thing. We're just pressing enter a lot of times because you have to get all the way to the end of the menu. You get the new calculators. So you're going to press enter a whole bunch of times until you get to the end. If you want to do it in Desmos, I'm going to show that on the screen. So we'll bring this up. This is the thing where we have to bring up our table. We got to type in our numbers, 0, 1, 2, and 3. The other numbers I don't know, 38, 41.5. All right, 43.1, 1.9. Okay, get rid of that, get rid of that. And we'll type in the code. So the code is, of course, y1 tilde ax1 squared plus bx1 plus c. If we want, again, I've found this little nice button here, the zoom fit. We can actually see the parabola. It looks kind of nice. I mean, your choice. If you want to press that button to look at the parabola, you can always just go home and say, well, I don't really need the parabola. I just want the numbers down here anyway. But it's cool that you can look at the parabola. And you can see it does kind of fit those 4 dots. All right, so we're kind of done, but we do have to write it in an equation. It does say find an equation, so if you just write these numbers, it's not right because you didn't find an equation. So the equation then is going to be y equals, and this is going to be for the x squared, so negative 1.175 x squared. So this is the a goes with x squared, the b goes with the x, 4.855x. And then the c is just the number, it's the constant at the end, 37.955. And again, even if you use the TI, you should get similar, if not the same numbers. Sometimes when you get to like 4 or 5 decimal points, they start to get different, but should be about the same. So again, you do have to remember the code, but the nice thing is if we go back a couple of them, hey, look, there's standard form right there in that question. So as long as you remember, all you got to do is put little ones after the x's and the y's. It's kind of already on the test for you. For number 20, we need to solve this equation. So to solve this one, we need to get everything on the same side because it is a quadratic. I don't really like this negative x squared, so it might seem weird, but I'm going to add x squared to both sides, which means I also have to do minus 8x to both sides. Usually we would just move the one thing over because why would you move 2 when you could just move 1? But I really don't like this negative x squared, so I'm going to make it 0 equals positive x squared minus 8x minus 48. And the reason I did that is if I look at that, I'm like, all right, I'm in business now because this is very factorable. I'm finding things that multiply to negative 48 and add up to negative 8. So I got to go through my list. So 48, I'm like, oh, okay, 48, that's easy. That's going to be 8 and 6. Oops, positive 6. But if I try to add these up, it didn't work. So I got to think of different numbers. Well, what about 14, or not 14, 12 and 4? 12 times 4 would be 48, so one of them's got to be negative. So negative 12 plus 4 does equal negative 8. So again, it's okay if you don't guess it right the first time. It just means you have to try something else. Since it's just a regular x squared, we're already factored. X minus 12, x plus 4. I guess the 0 is on the left side for this one. We'll keep the 0 on the left side. Which is another good reason why this one's a good one for a factoring choice as opposed to doing the quadratic formula or completing the square. So then to solve this, we'll use our zero product property. We solve each of the parentheses. x minus 12 equals 0. Add 12 to both sides. X equals 12. X plus 4 equals 0, minus 4 on both sides. X equals negative 4. And we're done. All right, cool. If you want, you can double check that with the graph or in Desmos to see if it does actually solve the equation. We're all set. For 21, identify the intervals where this thing is positive. So again, this looks like it's factorable. So I'm just going to go ahead and just jump right into factoring it. We need things that multiply to negative 8 and add up to negative 2. That looks like that's going to be negative 4 and 2. I just wrote 3. But negative 4 plus 2 is negative 2. So if we were to make this 0, so if I were to say that 0 is equal to x minus 4, x plus 2. Again, we can solve this with the zero product property. So add 4 to both sides. So x equals 4. Here we're going to subtract 2 from both sides. X equals negative 2. And now we get to make our sign chart. So we know we've got one number at negative 2. We've got one number at 4. Those are the zeros. So those are neither positive nor negative. And now I've just got to test my points. So if I plug 0 in here, I know I'm going to get negative 8. That's why 0 is an awesome test point. We know that that's negative. So that part of the sign chart is negative. If I were to plug some other numbers in, so we tried 0. Again, I like to pick 10 and negative 10 because it usually makes the math easy. So if I were to plug 10 in, 10 squared minus 2 times 10 minus 8, that's 100 minus 20 minus 8, that's 80, 72. So that's positive. If I were to plug negative 10 in, minus 2 times negative 10 minus 8, that's still 100, but now I get to do plus 20 minus 8. Well, that's 112. That's still positive. So I can see from my sign chart that the positive sections are going to be from negative infinity to negative 2. And we can union that with 4 to 10, because that's the other section that's positive. Oh, not 10, 4 to infinity. So there's not always two sections, because again, if it asks for which one is negative, the answer would just be parentheses negative 2 to 4, because there's only one section that's negative. But we have learned a little bit more this unit. So in Unit 3, we actually learned a little bit of a trick on this one. And that's, we can tell that this equation is an even exponent, so it's an even function, and its leading coefficient is positive. So we know the end behavior. The end behavior is infinity and infinity. So in this sign chart, we actually don't need to do the test points anymore, because we know that the ends have to go both to positive infinity. So we just know the endpoints have to be pluses, and from the y-intercept, we know it has to be a minus in between. So we can actually use the end behavior to not have to do a lot of the work here. So we can see that even though we hadn't learned that before, we can use the knowledge that we have now to help answer some of these questions a little bit faster. All right, for 22, use square roots to solve the equation x squared equals negative 196 over the complex numbers. Pretty nice. We're going to square root both sides because we want to get x by itself. This one we need to break down. We always break down into negative 1 and then whatever number we have, because we know the square root of negative 1 is I. Square root of 196, though, I actually know that. That's going to be 14. And so we're done. That's it. We don't have to break it down any further. If you were to try and break it down, if you didn't know it was 14, you should still try that number first just in case it works out. But if you wanted to jump into a longer method, we would say, well, it's even. Looks like we could divide that by 4. And we can also divide that by 49. And 4 is in our list of numbers that we said we needed to know. 49 is also in our list of numbers that we said we needed to know. So we would get 2 times 7 times I, which is also 14. So that would be the other way to do it if you didn't remember the square root of 196, or if you forgot to check square root of 196 with your calculator. If you go into autopilot mode, you still get the same answer. For 23, write this product in the form a plus bi. Again, we know a little bit more, so we could actually solve this one really quickly because we could see this is a minus b, a plus b form. We know we're going to get a squared minus b squared. But to solve it like we did before, just so we're consistent with the other test, 5 plus 2i, negative 2i, 5 plus 2i. 5 times 5 is 25. 5 times 2i is 10i. Negative 2i times 5 is negative 10i. Negative 2i times 2i is negative 4i squared. Combine like terms, which is actually going to cancel these ones out. So we get 25. Oh, minus 4. I squared, though, we know I squared is always has to change to negative 1. So times negative 1. 25 plus 4 is 29. And again, we can kind of see here, we had a minus b, a plus b. We got a squared because 5 squared is 25 minus a minus b. B squared. So we know that 2i squared is negative 4. All right, now the negative 4 shows up. Cool. So again, we can see that we could use the trick because 25 minus negative 4 is 29. So on the one side, it's a lot faster just to use the trick that we learned this unit. But again, on the left side, it did show how we did it before with the last unit. All right, so that's 23. We'll move on to 24. Write the quotient in the form a plus bi. We've got 7 divided by 3 minus I. We have to remember how to divide these. To divide, we have to multiply by the complex conjugate of the denominator. Since this is 3 minus I, we have to multiply by 3 plus I. So the numerator is not too bad because it's 7 times 3 plus I. So 7 times 3 is 21. 7 times I is 7i. So 21 plus 7i. To do the denominator, again, we've got 3 minus I times 3 plus I. So we've got a couple choices again, just like the last question was. This is just in the form a minus b times a plus b. So we know it's going to be a squared minus b squared. So we could just jump to 10 as the answer. Like you can tell the answer is just going to be 10, 9 minus negative 1. I'm going to write that down and just say, all right, 10 is going to be the answer. We will go through it, though, like we did on the previous quiz. The way that we solved this, we did go the long way. We said 3 times 3 plus I minus I times 3 plus I, which gave us, when we distributed, 9 plus 3I minus 3I minus I squared. These will cancel out. We said I squared is always going to turn into negative 1. So this is going to become 9 minus negative 1, which is 10. So again, we can just get the 10 the long way. But because we did some stuff in Unit 3, you don't have to do that anymore. You can just use the trick because it is an a minus b times a plus b. To finish it up, since it wants it in the form a plus bi, we'll write this as 21 over 10 plus 7 over 10i. And that's it. So I just divided each of them by 10. And that's the end of 24. So for 25, we need to factor this. All right, well, we're just going to use our tricks that we had. If we see here, we have a minus sign. We have to remember that we've got 2 perfect squares. So square root of 81x squared is going to be square root of 81 is 9. Square root of x squared is x. Square root of 25 is 5. Now, because we have this minus sign, we know we're not going to have any i's in the end problem. So we're going to write down 9x plus 5, 9x minus 5. Again, this is in the form of a squared minus b squared. This is going to give us a. This is going to give us b. So we know we need to end up with a plus b, a minus b. And that's it. Number 25 is done. It's a quick one. It's supposed to go by pretty quickly. 26, we've got this function. Which statements are true for x squared plus 5x plus 2? So first thing we want to do, since we have to find the range, we have to find a maximum, and we need an equation. It really looks like we have to get the vertex. So we're going to get the vertex first. To do that, we'll use our equation to get our axis of symmetry. X equals negative b over 2a. B is going to be 5. A in this case is going to be 1. So negative 2.5. Negative 5 divided by 2. I'm going to keep it as a decimal because I can see I've got a bunch of decimals in my answer choices. If I saw fractions in my answer choices, I'd leave it as a fraction. All right, well, now we need to get the y value. So to do that, we're going to plug negative 2.5 into this. Negative 2.5 squared plus 5 times negative 2.5 plus 2. All right, so negative 2.5 squared, that's going to be 5.25. 5 times negative 2.5 is negative 10, negative 12.5. And then plus 2 is plus 2. We'll combine our like terms, which is all of them in this case. So 12.5, we'll add those together, 7.25. So 4.25. Yeah, that looks pretty good. Oh, gotta be negative. All right. So if we look, we do have a h value that corresponds to negative 2.5, so those are both good. But our k value is negative 4.25, so we're going to pick A instead of B. Graph of the function is a maximum at negative 4, negative 2. That's not what we found. We found negative 2.5, negative 4.25, and I think this is a minimum anyway, so maximum is wrong, negative 4 is wrong, and negative 2 are all wrong, so that's out. The range of the function is y is greater than 2. We got a y value of negative 4.25, so we want to be greater than negative 4.25, not greater than 2. So I think we're going to be choosing A in this case. So A is going to be the only one, even though it says select all that apply. In this case, only one applied this time. But we did have to check all of them to make sure that the other ones don't work. All right. For 27, solve given exact answer. So since I see given exact answer, I know I can't use a graph. So I'm going to use either the quadratic formula, factoring, or completing the square. I don't know anything that multiplies to 3 and adds to 5, so I'm not going to factor it. 5 is odd, so I'm not going to complete the square. So my method of choice this time is going to be the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. B is 5. A, whoops, we're still dealing with b, plus or minus b squared minus, in this case, a is 1. We still got the 4 though. All right, now we can put the 1 in there. There's A. And C is going to be 3 all over 2A. We're going to simplify a little bit. Negative 5 plus or minus the square root of 25. 4 times 1 times 3 is 12. 2 times 1 is 2. Negative 5 plus or minus the square root of 13 over 2. And we can't really do anything with the square root of 13, so this is the final answer. If we could break that down, we might be able to break that down a little bit more, but we can't. 13 is prime. So looks like we're good to go there. 28, same question, give an exact answer. So again, graphing is out. That doesn't look like I want to factor that. With the 2 out front, same deal. I probably don't want to complete the square too much since I've got a 2 in front instead of a 1 in front. It might not be too bad to divide everything by 2 and then complete the square. But I think this one's well set up again just to use the quadratic formula one more time. So negative b plus or minus square root of b squared minus 4ac all over 2a. Negative 4 plus or minus the square root of 4 squared minus 4 again. A in this case was 2. C is going to be 11 all over 2a, so 2 times 2. All right, same deal as the last one, simplify it up a little bit. -4 plus or minus the square root of 16. 4 times 2 is 8. 8 times 11 is 88. 2 times 2 is 4. Simplify it up a little bit more. -4 plus or minus square root of, so let's see, 16 minus 88. Let's do that real quick. 272. All right. I don't like the way that 7 looks. I don't like the way that that eraser did. So -72. All right. Now this -72, though, we can break that down because that does have some numbers that would appear in our list. Most efficient way to do it would be to test 36 because we can break -72 down. Well, first of all, we're going to break that down. We're going to get rid of that negative sign into -1 and 72. So that's going to give us an I. But I think 2 and 36 is going to be the best way to do it because I do know the square root of 36. So the reason I picked these two is because I know the square root of 36, not for the 2. The 2 doesn't help me at all. The 36 does help because I know the square root of 36 is 6. So we can actually simplify this a little bit more into -4 plus or minus I and 6. That's 6I. I still have the root 2 left over. So I still have root 2 right here, all divided by 4. And I can simplify this even more because I can divide all of these outside numbers, all these outside coefficients by 2. So -2 plus or minus 3I root 2 over 2. So again, we're going to divide everything by 2 in this expression. So this one we get to simplify a lot. So not only did we get to break down the square root, but we also got to divide everything because we could divide everything by 2. All right. Next, we got 29. What values of b will cause 2x squared plus bx plus 18 equals 0 to have one real solution? In this case, the idea is we want to set the discriminant equal to 0. So the discriminant formula is -b. That's right in the quadratic formula. b squared minus 4ac. All right, well, we want to have the discriminant equal to 0 because that's one real solution. B in this case is b, so I'm going to keep it capital just so it doesn't look like a 6. Minus 4a is 2, and c is 18. All right, so we've got 0 equals b squared. So 4 times 2 times 18. Well, this is 4. I'm going to borrow one of these 2's to make this 4 times 4 times 9, just because I want to do it in my head. I don't want to use a calculator. I'm going to add this to both sides. And if you want to turn that into a regular number, you can. The reason I did this is because it makes it easy for me to square root them. 2 times 2 times 3. Since we did a square root, we do need a plus minus. 4 times 3 is 12, so plus or minus 12 equals b. So now that I know that 12 is my answer, this mystery number would have been 144. All right, sounds good. Cool. So that's number 29. We got our two values. For 30, solve, give answers to 3 decimal points. This is the key phrase that tells me that, okay, this is definitely one that we want to just throw into the calculator and solve graphically. So we're going to do that. So 5x squared plus 7x plus 2. 5x squared plus 7x plus 2. And then on the other side, we've got 3x plus 5. All right. So we want to find these 2 points of intersection. So they're a little bit more centralized on the screen. Okay, those look pretty good. We'll grab those and then we'll write our answer down. That's really big. I don't need it to be that big. That looks pretty good. All right, so our two answers we can see are the 2 points of intersection again. But we have to be careful. There's no y's in this question. So if we answer with these y coordinates, we're going to get the answer wrong. So you only have to put the x's down. So negative 4.72 and negative 1.272. So those are the answers. Those are both x's, so I don't need to put them in. That's not a coordinate point, so I don't put them in parentheses. I don't use any square brackets or anything. Those are just x values. Those are the two numbers. All right, for 31, what's the vertex of the graph of this function? You could solve this one by graphing if you want, but since we've been using the negative b over 2a formula a lot, let's just keep using that one. So negative 4 over 2 times 1. So that's 4 over 2, which is 2. And we plug the 2 back into this equation. 2 squared minus 4 times 2 minus 5. So 4 minus 8 minus 5 is negative 9. And that's it. So we're all set. That one's already done as well. That's a pretty quick one. Again, probably faster to do by hand than to type it into the calculator, but you can type it in the calculator if you want. 32, we're given a graph, and we have a whole bunch of function rules, so we have to find out which of these function rules corresponds to that graph. So it says use the zeros and the turning points to help us out. We can also use the end behavior to help us out. We can tell this is going to be an even, and we're going to need this to be a positive leading coefficient. So that's going to get rid of choice C and choice D. So we got only two choices to pick from. Instead of using the zeros, I'm also just going to use the y-intercept. It's 4. I know the answer is A. So that's pretty quick. If you want to do it on your calculator, it's going to take a while because you might need to check a couple of the answers just to see which ones actually match up with the zeros themselves. But that one's pretty quick with the end behavior and the y-intercept. 33, again, we're going to use leading coefficient to determine the end behavior. So in this case, we've got our degree here. Our degree is odd. And our leading coefficient is 1, but it's positive 1. So the LC is positive. So if I have something that's odd and positive, and we want to think back to our pictures we had, that was just like a regular line. So as x goes to infinity, we want y to go to infinity. That's this side. And on the other side, as x goes to negative infinity, y is going down to negative infinity as well. So I got to be really careful and read these correctly in order to pick the right choice. So for the first one, as x goes to infinity, y goes to infinity. So x infinity, y infinity, that's the one I want. As x infinity, y negative infinity, I don't want that one. As x goes to negative infinity, y goes to infinity. I don't want that one. As x goes to negative infinity, y goes to negative infinity. I do want that one. So two choices in this one. There's usually two choices for an end behavior question because you probably want one as you go to the left and one as you go to the right. For 34, we need to add these two polynomials up. Nice thing is we're going to combine our like terms. So here I've got an a squared b. Here I've got an a squared b. So those two are like terms. 23 plus negative 15 is 8a squared b. We've got ab squared, so negative 15 plus 17 is 2ab squared. 13ab minus 2ab, or plus negative 2ab, is 11ab. And then negative 4, sorry, our regular 4 doesn't really have a partner. So since we're adding, we just say plus 4. And we've combined all of the like terms. That's what we do when we add. For 35, we've got to multiply. No tricks here. We just have to kind of go the long way. So we're going to multiply the binomial times the trinomial. But we've seen this done with the double distributive property a couple times already in the review. X 4x squared minus 5xy plus y. and then 5y times the whole expression over here. So plus 5y times 4x squared minus 5xy plus y. So those are the times that we did the double distributive property. Again, we had a couple tricks that saved us from doing it the long way. Not so here. We just have to kind of go through with it. X times 4x squared, 4x cubed. X times 5xy is 5x squared y. X times y is xy. 5y times 4x squared is 20x squared y. Again, I'm putting them in alphabetical order. That's just common practice. 5 times 5xy, 25xy squared. 5y times y is plus 5y squared. Now we get to combine all the like terms. 4x cubed. I don't think there's any other x cubes. Nope. That stands alone. X squared y. X squared y. Okay, so negative 5 plus 20 is 15. All right. Up next, we got xy. That's it, just one xy. All right. Up next, we've got this xy squared. That's the only one of those. So 25xy squared. And then at the end, there's only just one 5y squared. All right. There we go. Nice big polynomial. When we combine like terms, again, we got to be really careful with all the squareds. Find out which ones are the squareds, which ones aren't the squareds. 36, use polynomial identities to factor 125 minus n cubed. That n cubed is a pretty big hint that it's going to be a difference of cubes. So to do a difference of cubes, we need a cubed minus b cubed is going to be a minus b. A squared plus ab plus b squared. So remember, for difference of cubes, minus sign is first, and then we switch to pluses afterwards. So we need a, we need b. So we need to do the cube roots here. So the cube root of 125 is 5. 5 times 5 is 25 times 5 is 125. And then we need, this is a. Not a very good a. And then the cube root of n cubed, cube and cube root are going to cancel out, so n is going to be b. All right, so that means we put in 5 for the a's. We put in n for the b's. And then with these ones, we always want to try and clean them up a little bit. 5 minus n, 25 plus 5n plus n squared. I'm going to be happy if you get it that way. We don't really need to throw it into standard form or anything for this one. That looks pretty good. Again, want to go quick with this one. We don't want to do any of the proofs that we did. We just want to go ahead and jump right to the answer. All right, so we've reached the end. So final question is, use the binomial theorem to expand a plus 3b to the 5th power. So for the binomial theorem, we know that we have to use Pascal's triangle for this one. So this time I didn't give it to you, so you actually have to figure it out. So it starts at 1, then we get 1's on the end. 1's on the end, 1 plus 1 is 2. That's not the one I want. I need the one that has a 5 as the second number, so I have to keep going. 1 plus 2 is 3. 2 plus 1 is 3. That's not the row I need. I got to keep going. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. That's not the row I need. I got to keep going. 1's on the end. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. That's the row I need because I see I've got 5 as my second number, or I can go 1, 2, 3, 4, 5th row. So already starting out to be a little bit of a long problem, but let's keep going because we're basically done, right? Once we get Pascal's triangle, we know that we're just going to use the form for a binomial theorem. So we're going to say, all right, we need the 1 from the Pascal's triangle. Then we need our first term. In this case, we have an a instead of an x, but that's going to be to the 5th power. And Our second term, instead of y, this time we have 3b. Well, that's going to be to the 0th power. Remember, again, you don't need to put the 1s or the 0s. The 0th power, that would just be 1. You can get rid of that if you want. But I like to put them all in here just because I have to show everything off. 5 is my next number from Pascal's triangle. And now we follow the pattern. We go down 1, so 5 minus 1 is 4. The 3b's are going to go up in terms of 1 power, so we're going to get 3b to the first. All right, next number in Pascal's triangle is 10. We've got a, we're going to go down 1 to the 3rd power. Our 3b's are going up 1, so we've got 3b squared. All right, next number in Pascal's triangle is 10 again. A's are going down by 1, a squared. 3b's are going up by 1, 3b cubed. All right, next in Pascal's triangle, we got a 5. A's are going down by 1, a to the first. 3b's are going up by 1, 3b to the 4th. Looks like I'm in the way, so I'll move myself out of the way. All right, final number in Pascal's triangle is a 1. A's are going to go from 1 to 0. Again, you don't need to write that if you don't want to. 3b's are moving up from 4 to 5. All right. However, again, since we see we've got numbers inside all of these parentheses, we know we're not done. We still have to simplify everything. So we got one more step to simplify everything. All right, so first term, remember this is just going to be 1, so we don't need to deal with that. This is a 1. If you multiply by 1, we don't really need it. So our first term is just going to be a to the 5th power. All right, second term, we got 3 to the first power is 3. 3 times 5 is 15, so we get 15a to the 4th. Now we still have this b over here, though. We have to include the b. I don't need to put the 1 if I don't want to put the 1, and I don't, so I'm not going to. Next term we have, all right, 3 squared is 9. 9 times 10 is 90. A cubed. B to the 2nd power. Okay, so far so good. Next term we've got, all right, so we've got 3 to the 3rd power. That would be 27. 27 times 10 is 270. I got a squared again. Well, not again, for the first time. And I got b cubed this time. All right, next one. So we've got 3 to the 4th power. That would be 3 squared is 9. 3 squared is 9, so 81. 81 times 5 would be 405. A to the 1st power, so I'm just going to write a, b to the 4th power. All right, I need one more color at the end. I'll take this orange one. Again, we've got a to the 0, which is just going to be 1. So that's a 1. So 3 to the 5th power, that'd be 81 times 3, or 243. And then b to the 5th power. And I just snuck it in there before I hit myself with the picture. Really long answer, really long answer, really long answer. But that is the answer. And again, there's not much work to be done there. If you want, you can use your calculator on some of those. Like if you wanted to double check what 3 to the 4th power was, that's totally fine. But that's it. That's everything for the midterm review.